See about this question: minimum insertion to balance a parenthesis string. So given a parenthesis, open parenthesis, if there are two closing parentheses, then it is balanced. Uh, so by default, any balancing parenthesis would come under stack. So this is also a stack based problem. So what we need to do is we need to check for conditions. What we're going to do if a stack is empty. So we'll initialize stack. So that would be my first understanding. So and based on various conditions, for example, if element I is open, so and if the stack is empty, if stack is empty and we get it, what can happen is, so if stack is empty, then we would need two more closed parentheses to close this stack, right? So what we do is we add 2 to the stack. Similarly, if top of the stack is 2, which means if top of the stack is 2, what it means is we got this before, open braces before, and that's why the top of the stack is 2, right? And in example, we got this, and after this we got one more open parenthesis. So in this condition, what we need to do, we need to add 2 to the stack. It's similar to stack is empty. Okay, and else if stack, top of the stack is 2, so this is top of the stack is 2 condition. So else if top of the stack is 1. So what happens here is how when this condition can occur. So top of the stack 1 means we got open parenthesis and close parenthesis, and immediately after this we got a close parenthesis. So what we need to do here is we need to add one close parenthesis here. So we'll add 1 to the answer, and then we would need to remove this, because once we add 1, that means this particular the parenthesis is balanced. So you would pop the element from the stack, and for the new close parenthesis we need to add 2 to the stack. Add 2 to the stack. So this are the condition which we can have if it is an open parenthesis. So basically the stack will have to either 2, 1, or it will be popped out. So if I has a close parenthesis, and if top of the stack is 1, so this would be, example would be this condition. So only in this condition the top of the stack would be 1, and if you are getting another close parenthesis, which means this is balanced, you just need to pop the element from the stack. Okay, then if top of the stack is 2, so if top of the stack is 2 means what happens here is we have this, right? We have this open parenthesis, and that is why we get top of the stack 2. So once this close parenthesis has come, so we need one more close parenthesis. So we would reduce top of the stack by 1. Else if stack is empty, so what can happen is stack is empty, and we got this. So which means we need to add open parenthesis to the uh, equation. So we need to add answer, increase answer by 1, and then we need to so which means we got an open parenthesis, we need a close parenthesis to the stack. So we increase answer by 1, and then we would push 1 to the stack. So because we need one more close parenthesis for the balanced equation to equate the balances, so push 1 to the stack. So this should do. Okay, so with this condition we should be able to approach this problem. Let's try this. If you're getting an error, we can revisit this algorithm. Okay, initialize the stack and initialize the answer by in S. So if I is equal to open parenthesis, so if it is equal to open, then we need to check if stack is empty or if top of the stack is 2. Then we need to add 2 to the stack. So if stack is -1, so in this case we need to add 1 to the answer, and we'll pop the element from the stack, and we also need to add 2 to the stack for the next 2 close parentheses. So need to append 2 to the stack. Okay, so this condition is over. Then if it is a close parenthesis, check if it's equal to 1. So if it's equal to 1, just pop. If it is 2, so if it is 2, you reduce the stack, top of the stack by 1. Else if there is no, this can only happen if stack is present. If there is no stack, if stack is empty, so you add answer by 1 and then you push 1 to the stack. Okay, once this is done, verify if stack is still empty and append the remaining stack elements to the answer. So this should work here. So we can try all the other examples as well. Let's try this. And we'll debug if there are any issues. Yeah, this works, so I'll just submit it. Yeah, this works. So main thing is, you need to have this conditions check, and if you can understand this, then this problem is pretty interesting. So you need to get this idea, and then just follow the algorithm. It should work out. Thanks guys, thanks a lot.